Hello, my name is Johan Akbar. My topic for my technical project is GPU and its evolution throughout its years. I'll be talking about GPU, its history, features and terms of the CPU, the difference between integrated dedicated GPU, and finally, I'll be comparing two of the latest graphics cards. What is a GPU? GPU is a short form for graphics processor unit. It is primarily used for 3D rendering games. The GPU also plays an important role in modern artificial intelligence. Other than that, the GPU can perform other tasks such as financial modeling, scientific research, oil and gas exploration, Bitcoin mining, and multimedia tasks. Such multimedia tasks are transcoding video and video processing. On the top right picture shows the task manager bar of the status of the GPU. As we all know, when the game is running or when the GPU is used, the graph will be going up and we can see from the graph that GPU is doing its work and how its status. We have the 3D status right here, the video decode, encode, and more status right here. The GPU versus CPU. The GPU is equipped with hundreds of cores that can handle thousands of threads at the same time. As for the CPU, it is composed with few cores with only a lot of cache memory, handle few software threads at a time. We can assume that the CPU is the brain and the GPU is the brain enhancer. The GPU can accelerate software 100 times faster over the CPU alone. And the picture right here is the architecture of how the GPU and the CPU looks like. We can see that the GPU has a lot more ALU than the CPU, which helps with computing and allows more threads to be handled. The next subtopic is history of GPU. If we think about it for a brief minute, when was the first GPU was created on what platform? It was used by the arcade booth game. That's where the first GPU was made. Therefore, we believe that GPU has been around for a long time. But the first GPU for the computer is a monochrome display adapter. It was able to display video of 80 columns and 25 lines of text and symbol. Another example of graphics card is the ISBX275. It was capable of displaying 8 unique colors on a 256 by 256 resolution. So it was a pretty small resolution with pretty much 8 different unique colors. The next GPU is the VGA Wonder, which was made by the ATI. It was paced and dominated the market for at least a decade. It is equipped with 16-bit, fully 2D, and comes with a mouse port. Probably the only time we seen or heard a mouse port on a GPU. The next graphics card is the Voodoo 1. It separates 2D and 3D, forcing the user to have separated cards. It has a 4 MB RAM, 50 MHz core, and an appropriate API that pioneered for 3D game development. It's actually a big step into 3D acceleration, I believe. Another graphics card is the Riva by NVIDIA. It does not have a better benchmark than the Voodoo, but it was pretty much accepted by all users. I figured that the Riva was cheap, that's why it was acceptable by all the users. And it benchmarked as good as the previous graphics card, which was the Voodoo. And the next example is the Voodoo 2. It was a 3D accelerated high resolution of 1024 by 768. It was one of the few first video card that supports multi-card support, which means you can use two Voodoo 2 cards to work on parallel on a single computer. The next graphics card is the GeForce 256. It was the first GPU that has 3D acceleration to support DirectX 7. quote unquote from a website. It's a single chip processor with integrated transform light, triangle setup and clipping and rendering engine that is capable of processing a minimum of 10 million polygons per second. It has a fast clock speed of 32 megabytes DDR RAM. So, what is the difference between dedicated graphics and integrated graphics? The integrated graphics card are graphics cards that are able to build in the computer, that are already built in the computer or the motherboard. It basically uses the system memory, so it uses the memory of the motherboard or like the RAM. And other than that, it's pretty cheap because you're paying for a two-in-one product. GPU is already built in the monitor. Other than that, it also generates less heats. A hybrid graphics card also exists, which has dedicated and integrated card. So you have the dedicated card, which is in the motherboard, and when you're running games, it'll switch into an integrated card. This case mostly happened on laptops. As for dedicated dedicated graphics card, it's what I call a standalone graphics card, where the motherboard would have a slot to take in the GPU. The GPU for a dedicated graphics card has its own built-in memory, also known as VRAM. It is perfect for gamers and professionals who use computer to run heavy graphics or heavy processing tasks. The GPU gets warm if its fan or cooling is not compatible, because it has its own power, which you would have to connect its power supply to the graphics card itself. And also uses a lot of battery for laptops, and other than that, it is expensive. I'll be talking about the important features, terms, and specs of the GPUs. The modern CPU consists of many units, amounts, and features of which determine the result rendering speed, effects, and the gameplay of task. The GPU clock rate. The GPU basically is the GPU operating frequency that measures in megahertz. High GPU rates affect the number of vertices and pixels that can be computed. The different frequency in GPU is to increase its efficiency. The next term is the fill rate. It's like how fast the graphics processor can draw a pixel. Other than that, it's a unified shared I believe it's shaders, unified shared shaders. It's where the pixel shaders and the vertex shaders are unified. And other than that is the DirectX 10. DirectX 10 is a collection of API handling multimedia, game programming, and videos. Compatible GPU depends on its unified architectures. So some GPU would support DirectX 10, or would support the latest one, which is DirectX 11, or they would support the previous version of the DirectX 10, which would be the DirectX 9. Other than that, it's the memory type that's built in the GPU. There's two types, which is the GDDR or DDR. All modern types are DDR or GDDR, where both memory transfer twice as much data at the same frequency. The GDDR differ from DDR in parameters and provide twice as high data transfer rates. The video memory size. It uses a built-in memory in GPU to store necessary data. Done. That's pretty much it. But in an increase of memory size, the performance is given a certain boost, but then additional memory fails to yield any gain. A higher memory size is good, but there are limits to the performance boost. Most important parameters such as memory bus width, and frequency. The raster operation unit. It writes computed pixel into buffer and blends, active use of post-processing filters, and enables anti-aliasing with high-quality game settings. This is most likely a great feature for the new upcoming games, where they would use a lot of computing to render the scene of the game. Other than that, it's a text mapping unit which cooperate with all shader fetching and filtering textures, data, and render a scene. Now I'll be comparing two current latest and the strongest graphics card, which is the RTX 2080 Ti by the Nvidia versus the AMD Radeon 7 by AMD. So the new RTX is a new Turing GPU architecture with features tensor cores for AI, thereby potentially reducing GPU usage during machine learning workloads, and RT cores for ray tracing, rendering more realistic image. The next graphics card is the AMD Radeon. The AMD Radeon 7 has a massive 16 GB of expensive high bandwidth memory, which offers a decent degree of future proofing and also makes it a good choice for memory hungry applications. Clock speeds have been boosted up to 1800 MHz. Here is the benchmark scores for both of the graphics card, which we can see the graphics card for the RTX comes in second of like overall graphics card that exists, and this is the strongest graphics card for the AMD company, which plays on 10th. As you can see, here are some of the rendering tests that was done by the software called User Benchmark, and as you can see, the results for the RTX is way higher than the AMD Radeon 7. But unfortunately, the RTX 2080 Ti would cost around a 1.2 grand, and as for the AMD Radeon, I believe it's around $900. And it's not. I'd like to take this opportunity to introduce a new release graphics card that was released recently on 22nd of February. It benchmarked as good as the GTX 1070 Ti, which is the graphics card that I'm using right now. And the good thing is that it's cheap and worth the value for a latest graphics card release. And I would recommend users to upgrade the graphics card if they have a graphics card lower than the 1000 series to a 1660 Ti series, as it benchmarks better than the GTX 1070 Ti. And I believe it costs like around 300 or 350 US dollars. Here are the benchmarks for the GTX 1660. As you can see, it's still new, so it does not have any new ranking, and the graph shows like there's only a few users that uses the software to test the benchmark. In conclusion, I believe that the GPU scene will continue to grow as there are many crazy demands on the market. Complex tasks and high graphics of games will also continue to grow, which affects why the GPU is growing. We should also appreciate how technology has grown throughout the years. As a person who has interest in technology, it's hard to keep up with its growth, but it's good to know how it started and how it evolves. Thank you.